Hi, today we'll be learning about some linear algebra concepts that will help us understand some of the machine learning models. And of course, these are actually basic building blocks of machine learning. Okay. So first we'll talk about proximity or distance metric, and then we'll use this distance metric idea to craft our first machine learning model. So we are given two data points of two categories. One is a blue circle and the other one is a green circle on a straight line, okay? And we represent their position as xb and xg, okay? And we found Mr. Bob, he claims that he is a good classifier, he's a good machine learning model. If you give him a new data point, he can perfectly classify it as one of these two categories, okay? So we say that, okay, can you classify this data point? We've quickly figured out that Mr. Bob got a little bit confused because the data point is almost at the middle point. We say that, okay, we give you a new one. So we shifted the earlier data point to the left, and Mr. Bob says that, oh, I know it should be a blue. How? Because it's closer to the blue circle. Basically, what happened? He used the absolute difference between their positions, and as the distance between xq and xb is less than xq and xg, he made his decision, okay? It's quite simple idea. So now let's move to a little bit more difficult case. So we move from 1D to 2D, okay? That is, our data points are now on a plane, okay, rather than on a line, okay? And we note this x1, y1, that is the blue circle, as p1 and the green circle as p2, okay? So we go back a little bit. So here was the absolute difference, and in this case it is a scalar, okay, because it has one dimension. In this case, we have to learn how to estimate the distance on a vector space. So we learned some distance metric definitions. The first one being L1 distance. This is also known as Manhattan distance, okay? So the idea is quite simple. You walk through per axis, okay? So in this case, I go to the x-axis direction by estimating what is the difference on the x-axis level, okay? And then I walk on the y-axis direction, okay? So x2 minus x1 absolute plus y2 minus y1, okay? If I draw a triangle here, then I am actually walking through the sides, horizontal one and then the vertical one, okay? So, and then I sum them over. So this is the idea of L1 distance, okay? You can do some practice. What is the L1 distance between 0, 0 and 2, 3? So it should be 2 minus 0 and 3 minus 0. Take their absolute values and then sum. It should be 5, okay? What would be the L1 distance between 2, 3 and minus 3, 1? Let's try. It would be 7, okay? So that's the general idea of L1 distance. Now we move to another distance metric that we are already familiar with, which one is L2 distance or Euclidean distance, okay? So in this case, we are actually estimating the diagonal distance, okay? And how do we do that? You take the square root of each deltas on the x side and y side, and you take the sum and take the square root, okay? So this is the formula, okay? Again, quite simple. You use to practice the two data points that we did for L1 distance estimation, and you found that the values are different than L1 distance, right? it's quite natural. The diagonal distance will be different than the other side distances. Okay, right? Okay. So, summary, we have learned about two distance metrics, L1 distance or Manhattan distance and L2 distance or Euclidean distance. So now we will use one of the distance matrices to craft our first machine learning model, what we call k-nearest neighborhood model. Okay. So now we are given a bunch of data points, okay, from two categories, a red triangle and the other one is blue squares. Okay. So we are learning a classification problem. Given a new data point, we have to tell whether it is a triangle or a square. Okay. And here is our new data point. We have to tell whether it is a triangle or a square. Okay. And we have intentionally put the new data point in the center of those circles, okay, because one of the parameters of the k-nearest neighborhood model is the k, okay. If the k value is 3, then you have to first identify the closest 3 points. So in this case, 2 triangles and 1 square. For k equal to 3, majority are triangles, so our decision will be this is a triangle. Okay. If we extend from k equal to 3 to k equal to 5, then we have to take into consideration all the data points that are within this dotted circle. And it turned out to be that if we choose k equal to 5, then our decision actually changes from a triangle to square. Okay, so that's the general idea of k-nearest neighborhood model, because it's a supervised learning model, because we started with some known data with their labels, in this case triangles and squares, and then we use some distance calculations, in this case Euclidean distance, with the value of k. We made our decisions that whether a given point is a triangle or a square. Okay. So so in the next part we'll be explaining another distance metric which is very popular in the machine learning community, what we call cosine distance. Okay. And here is the formula. The cosine distance is 1 minus your point P1, then you take the dot product of P1, P2, and then divide by the multiplication of their norms. Okay. We will be discussing in another video what are these concepts are. In terms of concepts, the cosine distance is the angular distance between these two vectors. Okay, so that's the general idea. Okay, for these 2 points the distance is 1, and for these 2 data points the distance is 1.26. Okay. Next I'll be briefly explaining some characteristics of these 3 distance matrices. Okay, because we don't only rely on L2 distance, which is more familiar with us. We introduce to some other distance matrix definitions, and we have a purpose for that. We will learn these things in our coming classes. One of the important characteristics of these matrices are their distance ranges. For example, for L1 or L2 distance, their range is between 0 to infinity. For cosine distance, the range is within 0 to 2. Okay. Again, if you have any questions, feel free to ask me. But in summary, we learned 3 distance metrics: L1 distance or Manhattan distance, then L2 distance or Euclidean distance, and cosine distance, because these distance definitions has their own properties and they are useful for different machine learning tasks. In addition to that, we learned about a machine learning model, what we call k-nearest neighborhood model, because that model actually purely depends on the distance between data points. Okay.